a first-order differential equation that can be written in the form g of y prime equals f of x, or g of y prime equals f of x dx, where y is a function of x, is called a separable differential equation. Similarly, a first-order differential equation of the form the differential dy dx is equal to a function of entirely x, call it g, and a function entirely y, call it h, is said to be separable. Separable differential equations. Once we determine that something is of the form, this is the method we're going to go about. We're going to take the first form that we had. Sure. G of y, a function entirely of y prime, is equal to a function entirely of x. What are we going to do? We're going to take our prime notation, we'll switch it to Leibniz notation, okay, and then what are we going to do after that? We're going to separate our differential. Alright, sure. And then after we have a function entirely of y, we're going to try to integrate that with respect to y. A function entirely of x, we're going to integrate that with respect to x. And then what are we going to do after that? In order to get a function for our dependent variable y, we're going to solve for y. And then what's that going to do? It's going to get us a function. Here's our first example of solving these separable differential equations. Okay, so then I'm presented with this guy. Y prime is equal to 10 to the x plus y. What do I want to do? I want to first change to Leibniz notation, and then I separated this into the product. Here you have the same bases and you're multiplying. What can you do? You can add the exponents, or vice versa. You can come down here. Now what do I want to do? I'm going to separate my differential and get my y's on one side and my x's on the other. Here I see I have this form over here. It's entirely of y, so I can integrate this side. Here this is entirely of x, so I can integrate this one with respect to x. But how do these integrate? So this is how we integrate when we have a base to the exponent, or we integrate an exponential function. If we take a look at this guy, man, if we're trying to integrate some base, which is a constant, okay, to u du, what's it going to be? Well, the form fits, and I'm not going to show it here because that's not the point of this example. The form fits. It's 1 over the natural log of u times b to the u plus c. Some of you guys are saying, well then why when I integrate e to the x is it e to the x? Here's why. If I had the integral of e to the x dx, yeah, that's going to be equal to 1 over, alright, here's my u, so my du is dx. I don't need a constant multiple out front. It's going to be the natural log of e to the x plus c. But here we see, what is the natural log of e? This is base e, so this dang thing is 1, right? 1. So what do you get? You get e to the x plus c. Okay, so this one over here on the right integrates just fine. Because I have my u and I have my du. But over here we run into a little bit of trouble. Here I'm going to let u be minus y. Then du is minus dy. Okay, so that means when I make my substitution, I'm going to have a minus on the outside of my integral. And then it integrates on up here. That minus on the outside of the integral gets tacked onto that product. So I have 1 over the natural log of the base times the base to the exponent. And then over here, I have 1 over the natural log of the base, and then I have the base to the exponent, and then I'm going to add that constant. Notice I should have added that constant to both sides, but I can add it to just one side. Had I added to both sides and then subtracted it over here, a constant minus another constant is just a constant. Okay, so that's C1. Very nice. So now what do I want to do? I want to solve for y. That's my last step. I'm already done with the integration. Yeah, so I'm going to multiply both sides by the natural log of 10, or minus the natural log of 10. And then, when I do, it's going to reduce with that one, or cancel, leaving just minus 10 to the x plus minus the natural log of 10 times that constant. Now, what did I do over here? The natural log of 10 is just a constant. So a constant times a constant is just a constant. I constantly called it C2. So now what do I want to do? I still want to solve for that y. Why? Because I want a function for y in terms of x. So then I need to go log in. I need to take the log of the appropriate base of both sides. Here I see that's a 10, so if I'm going to use the appropriate base logarithm, it's going to be the common log, or log base 10. Okay, so I go logging on both sides. Yeah, so log base 10 of 10 of the exponent is the exponent. And then I'm just going to leave it alone. If I don't write a number in the base of that logarithm, then it's assumed to be the common log. Okay, so then lastly I need to multiply both sides by a minus, and I'm left with this nice tight package. Box and flower.